Good morning, everyone, and welcome in this webinar about Mathcad Prime 11. Um, I will be your host, and I will start with introducing myself, a very short introduction. My name is Jan Kleijs. I'm a CAD consultant working for 9 Altitudes. I'm based in Belgium. I graduated as a Master of Science back in 2002, and I worked during 19 years in industry, mostly in machine building, as a design engineer and as a R&D engineer. And during that period, I made a lot of engineering calculations, mostly in Mathcad. And I think the first time I used Mathcad, it was version 13, uh, more or less 15 years ago. And since then, I developed a strong love, so to speak, for Mathcad. So I'm very enthusiastic to tell you about the new features in 11. So I work for 9 Altitudes. Very short introduction. So 9 Altitudes is an international company which was founded back in the day in Belgium and Denmark. And since then, it has developed quite strongly and mostly since the acquisition of Integral Group back in 2023, we are quite internationally. So we have now divisions also in Spain, Portugal, Turkey, and even in South America. So as a result, we are able to help our customers with a very large engineering team with a lot of specialists, which is very good for our customers, of course. We are focusing on the digital thread, interconnecting the main corporate entities of our customers. Today, we are dealing with engineering tools, so Mathcad, I will start straight ahead with that one. So first of all, a short sneak peek on the Mathcad product timeline. So starting from version 10, there are 2 releases a year. That means a new product, such as now with 11, is introduced in the spring, and later in the same year, so in the fall, there is a short upgrade. So that this will always be the case as of now. Also for 11, so normally around September, October, there will be a new version 11.0. It's not a new version, it's a new build. Okay. I come back to that first 11 before I discuss the 12. I will start with some important application updates in 11. The first one is the manual calculation mode. This is a feature which was also present in the Mathcad 15, so the first version when PTC acquired after PTC acquired Matsoft, and I will show what I mean with that. I think it's more useful to show that in practice. So we have a worksheet, and especially for long worksheets, it can be troublesome to resolve issues when we have, for example, 100 pages in the document. And for that, we can deactivate the automatic calculation, because at the bottom of the screen we see auto, but when we press the button, we go to manual mode. And what is the advantage? For example, when I make a change in a worksheet, so here I will increase the slope ratio of a certain hill, then you will see that the calculation is halted. And if I place my cursor, I can say calculate now, and then the worksheet will be calculated up to that point. So if I press now, you will see it's calculated up to this point, but not further. So if I go further in this worksheet, you see that this is grayed out. This is quite interesting because it allows me to debug my worksheet. as I progress through my sheet. So this is also personal experience. This can be really uh, difficult when you have a quite long document. So now I can troubleshoot zone by zone. So if I go further, I click calculate now, you see I can progress to my worksheet. Of course, when I decide, okay, I have resolved the issue, I can also calculate the whole worksheet in the manual mode. So if I press calculate worksheet, it will have the behavior we know from Creo 10 and Creo 10, whatever, Mathcad 10 and previous versions. So this is an innovation in the first innovation in Mathcad Prime 11. So the automatic, the manual calculation mode. That's one. Two, starting from 11, we can use custom unit systems. This is also a feature which was present in 15. So you see PTC does a lot of effort to close the gap with the functionalities that were present in 15. And in this case, I go back to my sheet. It can be useful from time to time to change the standard unit system. So for that, I need to go to the ribbon to Math and then unit system. And here we see normally in Europe, we work in the SI system, but if I choose to deviate from that, I can indicate to use a custom unit system. And for example, in this case, I have made a calculation in which the result is calculated in meters and the velocity in meters per second. I can deviate from that. So for example, length, I can say, no, I don't want it in the standard unit. I want the length in, for example, what will we take in mile? And then that is the base dimension, length. So the derived unit is velocity. And normally it's in kilometers per hour. I can change it to miles per hour. And now when I click OK, just see what happens with these two results. We see that these are recalculated in the units I want. So in certain situations, this can be very useful. But watch out, this is only the case for results that are asked in the standard unit system. Sometimes I explicitly define a result in a certain unit, and in that case, the unit will not be changed. That's it. That is an important remark to make. I hope that is clear. So the custom unit system, it was quite high on the list of functionalities for 11. A third innovation when we are talking about application updates is the introduction of the Python scripting language for the advanced controls. I hope everybody knows that advanced controls were introduced in Mathcad Prime in version 10. And as of now, so just before version 11, only JavaScript and Visual Basic script were supported. These scripting languages allowed to customize the behavior of the custom controls. I will show it in my worksheet. For example, I have a list here. I can right click on it. I can modify it. And here we see the different possibilities for the scripting language. It's starting from 11. 11 will detect the presence of Python automatically. So that means if Python has been installed, I'm able to select Python in this list. And then I can modify the behavior of the control, whatever I like. And I have a small example of that. My Python skills are quite limited, but thanks to some colleagues, I have an easy example. So In this case, this is a very basic program in which we will generate a matrix with random values. So this is the Python program. And when I click the button, we will see that the contents are refreshed with every mouse click. So this can be useful in situations in which we lack functionality in Mathcad, or we want to expand the existing functionality in the program. When, of course, it's quite important that Python is installed. When it's not installed, I pasted the message from Mathcad, so it will be signaled to the user. So that is an addition to the advanced controls in 11. I added the versions. So for JavaScript, it's ES3, and for Python, all versions between 3.7 and 3.13 are supported, in which 3.13 is the most recent version of Python. Okay, so that was something about the advanced controls. Our next introduction is the use of binary, octal, and hexadecimal numbers. Also, this introduction originates from the original Mathcad 15, and I will show how it works. So in 11, when we click on calculations, here in calculation options, a new button has been added. And this button activates the binary, octal, or hexadecimal mode. When it's not activated, Creo doesn't, I will say Creo, Mathcad doesn't recognize the input. For example, when I have a binary number 101, so I added the table on purpose, that's the decimal number 5. When I say 101, I have to type it correctly, and I type B, Mathcad thinks it's a multiplication. And since B is not defined, I will get an error. In order to cope with this, I need to activate the binary octal hexadecimal mode. And starting from now, when I do the same, 101B, it will paste the B, so to speak, to the value. And as a result, now it is able to interpret my input. So now you can see the input is translated to a decimal value. A very small and easy example here. So I did the calculation 15 minus 5 3 times. So in these 3 columns, in the first column, I did it with the binary notation. So every time I look at the table, so 15 is 3 times 4 times 1, and I do the multiplication, and you see every time I have the same result, which is obvious, of course. One small remark: when you use hexadecimal notations, don't forget to add a 0 in front of the F. If not, it won't work. That's the reason I marked it in yellow. So it's 0F, not F. Otherwise, it won't work. Another important remark: I can format the result in the format I want. So to do that, of course, I go to Math Formatting, and here I can change the formatting. So in this case, the result is 10 in the binary notation. If I want to do it, if I want to depict it in octal notation, it will be 12. I can ask the system, please show me in octal notation, and we see this is the result we want. So I can format it whatever I want. Voila. I hope this is clear. So the support for these kind of numbers is okay as from 11. And next introduction or next new feature is the formatting of results. And for that, I think it's the best just to show it. When we go to math formatting, we have three values here. We have a formatting for complex numbers, and we'll start with that. So I have two examples. So as everybody will know, a complex number has a real and an imaginary part. And if one of these parts is bigger than the setting here, the smaller part will be suppressed, meaning that here you can see the biggest part has a value of 4. Since 4 is bigger than 3, the smaller part in both situations will be suppressed. So you see the result in the right column. If not, if I increase it, you will understand that this is not the case. So this is the meaning of the first formatting option. The second one, I think this is quite obvious, is the setting for the zero threshold. This means if I have two values, two variables, I can define a setting. So in this case, every value which is smallest than minus 10 to the negative power of 15, the value will be 0. So that means if I do since 5 times multiplied by 10 to the negative power of 11 is smaller than 10 to the negative power of 10, the value is 0. I think that's quite clear, at least I hope. And then the last one is the possibility to convert the value to exponential notation. It means if a certain value is bigger than 10 to the power of the value we see over there, it's converted to exponential notation. So in this case, you can understand I have 250,000. It's smaller than 10 to the 6th. So but if I decrease the value, you see the results will be converted. So this is a new feature that allows the formatting of results. Okay, I will send this worksheet to all attendants so that you can play a little bit with this feature. Okay. Then a smaller introduction, it's the use of region borders. In engineering calculations, a lot of times we want to emphasize a certain result, a certain input, just like it would be the case in a mathematical textbook. As of now, that's quite easy in Mathcad. We just need to, for example, this result, we select it, and by right-clicking, we can ask to show the border. So, and this will be visible when, for example, when we print it to PDF, just to emphasize this result. This also works for entries in a solve block, for example, like this, right-clicking, voila, and we have the borders. So that can be useful in a lot of situations. Of course, the border around the worksheet you see over here was already present in previous versions. So that is the frame we see over here. That's not a new feature. It's not more than that, but since it was also present in 15, PTC did an effort to include it in the newest version. So these were the most important application updates. Now some major engine updates, because of course these are very important. And the first one of that, I think everybody who works a lot with Mathcad will smile now. In the past, I think everybody struggled a little bit with the definition sometimes of vectors and range variables. So on the left of this slide, I just showed a small example. It's a small program that generates a certain vector because the functionality was not present up to version 11. Starting from 11, we have a new function which is called vector. I will show it in a minute, which allows the automatic generation of a vector. And not only that, it allows the conversion of a range variable to a vector, which is a very common practice in engineering calculations, and it was possible in the past. So you see here in the old screenshot, this was a trick known by a lot of Mathcad users. So this trick still works, but the trick on the right with the evaluation sign didn't work any longer in Mathcad 10. But no worries, I will show how it is implemented now. So there are different possibilities. The first possibility uses 3 arguments in which the first and the last one are the start and the stop values, and the second argument is the increment. So it's quite obvious in this case, this will be the result, but there's an important remark to make. The 3 arguments should be subsequent, meaning that the second value or the third value has always to be bigger than the previous value, meaning that if I have an input like this, 2 to 10, this won't work. Voilà. Because you see the error, the arguments must be sequential. So meaning that if I type a 4, it will work. Basically, what does it do? It distracts 2 from 4, and then it will create the vector. So this is something you have to keep in mind. Watch out with the values you enter when you use 3 arguments. The second application only requires 2 values. So only the start and stop value, and the increment will always be 1. Here I see something, I think this will make a lot of users happy. This is a very common situation. So you have a range variable, and this range variable, of course, is not a vector. As a result, you cannot use one of the elements of the range vector. Starting from now, thanks to that new vector function, you can convert a range variable to a vector, which we do over here. And in order to check if it's really if it's really a range variable or not, there is a new function with the original name is range. So in this case, if we ask Mathcad, is R1 really a range variable? It says yes, it is. And after the conversion, it is not any longer. This is useful because it's not always, for example, if I ask this one, the result, you can say, that's a vector. No, it isn't. And by using this function in a program, we are sure that you are dealing with a vector. So I hope this is clear. We stay with it within the numeric engine. The second improvement in Mathcad Prime 11 is the fact that when we are dealing with solve blocks, more specifically with the optimization functions, so we use the correct name is objective functions. In other words, functions that are maximized or minimized in this case, we can scale these functions. What do I mean with that? I scale the values in this function, for example, with a combo box like here, and then the solve block will deal with it immediately. This was not the case in Mathcad Prime 10. And to prove that, I paste exactly the same situation, and then we see starting from a certain scale factor, Prime gave problems. This is not the case any longer in version 11. So this is a second improvement. A third improvement is more or less in the same area. This deals with the scaling of constraints. So if you have constraints in a solve block, in this case, it's a quite easy example because the coefficient is on both sides of the equation. In other words, result will be the same. But even then, this gave birth to problems in Mathcad 10. This is no longer the case. So if I now scale the constraints, the solve block will always give a result and the correct result. Last but not least, the importance of the convergence tolerance parameter has been increased. The CTOL was already present in previous versions, but now when we increase the convergence tolerance, it means the CTOL parameter will look at the difference between two subsequent values of the constraint, and if they are below a certain threshold, then the solve block will generate a result. In the past, this had no results or had no consequences for the results, which was in a way not logic. But now we see, if we are looking at the results, if we increase the value, I hope it will be visible here, you see that the result changes too. So it has also consequences on the accuracy of the result. This was not the case in Mathcad Prime 10. I did exactly the same in 10, and you will see the value is not the same. The value was the same as for 10 to the to the negative power of 3. So this is also an improvement when solving problems like this. A last improvement when you're talking about the engine is concerning plots. More specifically, plots that include a lot of iterations. So in this first example, I admit this is not very useful from a mathematical standpoint because we repeat a function 1,000 times, even when the I is not used in the function. But this was a problem in previous versions. Now it is not any longer. So Mathcad has no problems anymore with increasing the number of iterations. This is the first example with the contour plot. And we have also a second example with a function like this, in which we have a sum which is repeated, which is used 1,000 times. So this kind of plots also work quite fast, while they were quite painful, so to speak, in previous versions. You see, it still takes some time, but it's a lot faster than in Mathcad 10. Voila, that is the results. Back to the presentation. So I hope this is clear about the new vector function. I showed the solve block improvements and also some examples of plot improvements. A lot of situations you will see that 2D plots are a lot faster in Mathcad Prime 11. Then we stay within the engine, but now we go to symbolic calculations. And a first important improvement over there is the introduction of a new keyword. I will show it live. For example, in this case, I have a series development for a tangent function. This kind of result can be quite unclear, meaning that there are a lot of coefficients and it doesn't allow to understand a certain system behind it. As of now, when we go to the symbolics menu, we have a new keyword, decomp, and this keyword will introduce coefficients. So you see, in this way, the solution is presented in a more structural way. This is a very basic example, but this is this is a more decent example of a quite simple equation, a quite simple function. But even then, back in the day, it was not possible to solve this in a symbolic way because the solution was too complicated. But thanks to the new keywords, thanks to the introduction of these parameters, Mathcad is able to present the solution in a more structured way. And in doing that, also let's call it the intelligence of Mathcad has improved, in that the structure of the solution is more clear than it was before. So this logical structure has been improved a lot in 11. Okay, we stay within the symbolic engine, and a small word about the simplify keyword. We can see that the simplify keyword has become a lot smarter compared to version 10. So these are some more complex examples in which we have a quite easy or basic result, but even then in Mathcad 10 this was not solved in a correct way. So simplify has been become a lot smarter in 11. This also applies for integrals. Here are a couple of examples. So in previous versions it took a lot of time, and I have to be honest, depending on the complexity, it still takes some time, but at least the result is correct. So when we see these two integrals and we compare it with the situation in 10, we can see that it has been not only improved, it's also correct. And the last example shows the improved, let's say, reporting capabilities of the symbolic solver. So I think that's a good thing for everyone who is involved with symbolic calculations. Okay, I have to go back here. So yes, I dealt with everything on this slide. To conclude, some usability updates. And the first one is about the radio button. Quite important remark to make about that functionality. Back in Mathcad Prime 10, I have to, of course, select the radio button, and I placed one over here. When we added a radio button, a new line has been added by default, this line more specifically. It means if we use a radio button, we can indicate which option is the default one. This was not the case in Prime 10. I have made a screenshot here. In 10, I was able to make a control like that, and it was possible to not select an entry, and as a result, the calculation was not correct. So now this problem has been avoided by the presence of that preset line. So I think that's a good thing. A next improvement, when we are still talking about the advanced controls, is about the slider. When I modify the slider in the properties, I can now indicate the minimum and the maximum, which is very convenient because, yeah, back in the day, it was not visible. Now, at least I can see, okay, this is the extent of this specific variable. So that's a first improvement. A second one is that I can invert the scale. So now it's from 0 to 0.3. If I invert it, we see the result. This can be useful in some situations to test our model. So small improvement over there with the slider. Okay, so this is about the advanced controls. And then a small improvement about the insertion of images. Before 11, I think everybody remembers the moment you inserted an image, you got the button in the worksheet you see on the left. This button has disappeared. So as of now, when you say where is it, image over here, it's the standard behavior you see in every Windows program. So you can directly select an image, and there it is. So this is a small improvement with the insertion of images. So there is no button anymore like on the left. Then a small introduction about page numbering. There's a new option in the page numbers in which the total number of pages is indicated between brackets. I will show what I mean. So in this case, this is an existing formatting of the pages. If I go to the footer, first of all, I need to delete the existing one because I can't have two indicators in the same worksheet. Then I go to page number, and here this one is new. So this is not very important innovation, but anyway, this was not possible in before. So a new way of numbering the pages. Then, and maybe an important new feature for everyone who is involved in the conversion of old worksheets. So more specifically, old worksheets containing protected areas. I will show what I mean with that. If I go to the input output, I have installed. So please be aware that you have to install this feature when you install Mathcad. If not, it won't be available. So I launch it, and I will add a legacy Mathcad worksheet that contains a protected area. I can, first of all, I will show what is in that worksheet. So to do it in a quite fast way, I can convert it, I can save it as HTML, I can right click, I can ask show it to me. And this is the situation. So I have a region which is protected, and it's protected in such a way that it's always open. So I can, the moment I make that area, I can define that. So, and it's protected with a password. And back in the day, with older versions, this was not possible to convert to the newest Mathcad version. Now it is possible. If I convert the worksheets, which I will do now, it won't take long. It's a page of an old PTC manual. I can open the converted file. Voila, there it is. And here we see that the protected area has been converted in a correct way, and the protection is still present, meaning that I cannot collapse it. So in order to be able to do that, I need to unprotect it, and the password has been converted too. So it's the same password as it was in the original document. So this can be useful for customers with a lot of legacy Mathcad documents with protected areas. I hope this is clear. I go back. This was the last feature that I wanted to show. Maybe before I ask if there are any remaining questions, I have an overview of PTC that deals with the future versions, meaning 12 and later, because I got the question quite a lot from customers if it's possible to align regions and worksheets just as it was possible in 15? Well, unfortunately, that it's still not possible in 11. So it's on the list of PTC, but it will be for a future version. So here I include this slide just so that you are aware of the points that are on the desk of PTC. Also, be aware or just know that PTC is working on a SaaS version of Mathcad Prime. So just as it is the case with Creo Parametric and Windchill, Mathcad Plus will be released in the near future. Voila. So I just wanted to show this information. I don't know if there are any questions when you see all this. If so, please shoot, and I will try my best to answer them. I see no questions. Or if there are complaints, just shoot. Anyway, I will provide the worksheets I showed in this presentation to all attendees. So I'll provide them to my colleagues. So we will send both the presentation as the worksheets so that you can have an idea, or you can just test the new functionalities. If there are no questions, I hope I did my work well and everything was clear. So I think we can conclude this webinar. So I would like to thank you all for your presence. And in case of any remaining issues or questions, don't hesitate to contact me or my colleagues. I will be very happy to assist you with these matters. Thank you for your presence and have a nice day.